couple of years ago, I made a 18650 Powerwall to go with my solar installation, and started off as a 60p 14S system, straightforward 18650 pack, and then I found that the capacity that I'd made was just under what I wanted, or you always need more. So I had a look at all the leftover bits and bobs that I had from when I was stripping battery packs, and I decided to make some expansion packs to add on to the back of the existing packs, and that consisted of a certain amount of 18650s and some prismatic cells, which I had a lot of. So I made 14 of these up, which added another 2 kilowatt hours or so to the system in total. However, earlier this year I had a look, and one of the packs looked a bit like this. Not ideal. So I took that out straight away, and I thought it was time for some maintenance and a bit of an upgrade. So I got some more batteries, and decided to change the 60p plus these expansion packs for 100p 14S 18650 packs, leaving out the puffy cells. So the other thing I wanted to do was to try and make it easier to build, maybe, and a bit more self-contained and neater. I made up these circuit boards. Idea being, this is both the bus bar, which will fit on there, and it will also have the balancing circuitry on, just the standard balancing stuff out of a cheapo BMS for the moment. I've put on a connection so I can enable it directly, so when I do something more fancy I can balance them at a lower voltage than the maximum that they currently balance at. So got a pack of those from China, so I'm going to use those to make some more packs. In order to spot weld those packs together, I will be using this. Now, the previous batch of battery packs, I used this with this beautiful bit of engineering here. Just a couple of UK mains earth pins with a couple of bits of copper wire screwed in, and that worked, just not terribly ergonomic, and the copper wire quite often needed fettling to get it to actually spot weld nicely. So the plan is, I bought some proper spot welding electrodes for doing this sort of job from Amazon, and I also got a piece of copper bar which I plan to mount in here like that. I'll figure out a way to connect the power leads to it in a bit, but I'm going to split it down the middle so I can fit an insulator between, and then grub screw in the electrodes, and then I'll have a nice, slightly more ergonomic pen to zap the fuses and bus bars nickel strip on with. So cutting bar in half is, especially that way, not terribly easy job, so I came up with this. This is a semi-sacrificial block, which I'm going to put on the bandsaw, saw just through here up to where it hits the stop on the bandsaw, and then I should, in theory, be able to push that through and then use a pusher just to finish it off. and I should end up with two roughly equal halves, which I can then machine to size. So let's give this a go. Right, so I'm going to try and skim these flat and square the ends, and then I'm going to drill a hole down the end and a grub screw in the side to fix the welding electrodes. I'll have to do another hole at the other end somehow to fix the power cables, but we'll get these squared up, if that's the right term for a half round bit of metal first. Okay. I haven't actually milled this one to length yet, so this one's shorter. There we are. That end has got a complete flat edge to it, so I might trim this end off just so that it's got a, and clamp it together nicely. But hopefully we've now got a reasonable amount of material removed. Be a blade width plus whatever we took off here, but I'll deburr this, get them in, and measure it with some feeler blades. Without even trying, I've managed to get a gap of 1.6 millimeters between these two halves, which is bang on for a piece of copper clad circuit board. So I'll chop out a piece of that, and that will be the insulator that will go between the two. Well, that fits nicely. Need to trim the end to get them not quite the same length at the moment, but we'll figure out how to attach the wires next, I think. Try that. Right, so it's about 3 millimeters in. It's not bad. Not a bad push there. Now, these two electrodes are such a good fit, actually, that I don't think I'm going to bother with the grub screws straight away. See how we get on. Probably be fine. So now I've just got to do the preparation for the back end to fit the wires. Right, so decided to mill a slot in the end. Just solder the wires in. I think that's going to be the best electrically. One thing I hadn't mentioned is why I'm using giant slug of copper to make this pen job. I found with the high quality version that I had before, it got very, very hot in use. So I'm hoping that a bigger slug of metal, which is highly conductive, should maybe have a bit more thermal mass, so take longer to heat up, and hopefully be less resistive on the bit that I'm holding. I think the wires are quite resistive, and of course the electrodes are quite resistive because they're quite narrow. So hopefully this won't heat up nearly so much as the rest of it. Find out when we try it. So right now I'm just going to mill about a 15mm slot. Fairly rough, but it's going to be soldered too, so that doesn't matter. Right, well, I've filed those and soldered them and everything, so they're close to flat. There's a bit of PCB material. Just going to put it up a little bit like that, so prevent the two cables from touching. And then if we slide that on from that end, good enough. Right, let's see if it welds. Right, so the first thing I noticed is the electrodes are only just close enough together, not sure if you can see that, to see if I can get a cell out. There we are. So on a cell like this, they're right at the edges of the positive terminal there. So let's bend them in a bit. A bit closer together. Do. Now on this welder, normally if you're doing proper spot welding, the electrodes clamp together on a piece of metal. You squeeze the handle down, and you end up pressing that micro switch just on the end there. There's a timer that sets the time, but I don't think that works when you're doing it like this. I don't seem to be able to get it to time out, so it's a matter of just pressing the button briefly and it does a weld. So let's see how all this welds. Yep, it welds. I think what I might do is strap these wires together so that they're more of a single cable rather than two wires flapping around, but that's immediate impressions, or it's an improvement. Let's try a different cell. Yeah, it's working nicely. Doesn't stick. The copper wire electrodes on the old one generally stick quite a lot. They haven't so far. There's not many welds yet, but yeah, that's a win.